Welcome to Study Loop.
Okay, so here we want to calculate the potential difference across the 5 kilo ohm resistor, which is connected in series with a 6 kilo ohm resistor, and they are both connected to a 50 volt power supply, right? A 50 volt battery. Now, the potential, voltage voltmeter has a resistance of how much that is? Internal resistance of 10 kilo ohm, right? So this is the resistance of voltmeter, that is equal to 10 kilo ohm. All right, so let us consider that this is R1. Now this is R2. Now, due to the presence of voltmeter, the R2 won't be R2, but it would be R2 prime, that is due to the influence of the voltmeter, and that would be R2 parallel RV, right? Because the voltmeter is in parallel with the 5 kilo ohm resistor. So this should give me 5 parallel 10. Now what is 5 parallel 10? That is 5 into 10 upon 5 plus 10. So that gives me 3.33 kilo ohm. So the new R2, that is R2 prime, would be 3.33 kilo ohm. Now this whole setup here, this whole setup is R2 prime, to make you understand. This whole setup is R2 prime, right? Now the potential that it would measure, V, would be equal to R2 prime upon R1 plus R2 prime into 50, right? Now what is R2 prime? 3.33. What is R1? 6. What is R2 prime? Again 3.33. So into 50, which gives me 17.86 volts. Alright, so this is what the voltmeter measures. We are done with part A of the question. Now, what would be the true potential difference? The true potential difference would be such that the V does not have any internal resistance. Then the V would be simply R2 upon R1 plus R2 into 50. Now what is R2? 5. So 5 upon 6 plus 5 into 50. So this gives me V equals to 22.73 percentage. This was obvious, right? Because the true voltage is always greater than that measured by the voltmeter. Now, by what percentage is this high? So the percentage error equals to the true value minus the observed value upon true value, right? Into 100%. Now this, if you calculate this, gives me 21.4 percentage. So this is the percentage error, and we are done with the solution of